Okay, let's unpack this. Imagine a construction system, right? One that claims it can fundamentally change, well, pretty much everything: the speed, the strength, even the whole life cycle of a building.
Hmm.
That's the promise we're deep diving into today. We're focusing on this one specific modular architecture system, and it's built around four big claims: strong, lightweight, sustainable, and certified.
Exactly. And our sources here, they're quite technical.
Hmm.
We're looking at the documentation, the structural specs, and also, really importantly, the global business side of things for MHS building systems.
Right.
Because, it's one thing to invent something cool, but engineering the scalability,
Yeah.
that's a whole different
Yeah, it
ballgame.
really is the challenge, isn't it? I mean, traditional construction, it's slow, it generates a lot of waste, and it's so dependent on specialized labor that's, hard to find sometimes.
Well-
So our mission today is basically to cut through all this data, all these specs, and figure out what makes this aluminum-based system genuinely unique. Is it just the sheer strength they talk about, or the business model for rolling it out globally? We need to figure out if this is like the real future or just another niche idea.
And what's interesting is how the core engineering seems to directly feed into the sustainability part and the business goals. They're aiming for simpler logistics, using standardized panels and frames.
Uh-huh.
That should make global fabrication and shipping easier, which, let's face it, is often a massive bottleneck for modular building.
Okay, so let's start right at the foundation, the engineering. What's the material science here? What's the core concept behind MHS that they think can really change the game for modular construction?
Well, it all kicks off with the material they chose. 100% recyclable aluminum extrusions.
Aluminum.
Yeah, and that choice seems really deliberate. It tackles weight, obviously, but also end-of-life waste right from the start. Aluminum means zero waste modularity in theory, and it holds its value really well. High salvage value. Unlike steel or wood framing, which often just ends up in landfill, this stuff is naturally corrosion resistant and totally reusable.
Okay, sustainability sounds good. But historically, you think structure, you think steel, you think concrete, brute force, right? Aluminum's light, sure, but we need serious strength.
Yeah.
That's where these claims, and especially the certified part, really have to hold up. Let's dig into the main structural component, the MHS 170 series, their primary structural frame.
Right, and these aren't just like standard aluminum beams you'd pick up anywhere.
Yeah.
The 170 series profiles are pretty beefy, 6.69 inches by 6.69 inches.
Okay.
They're tested to ASTM B221, which is, a necessary standard for aluminum alloys, but that's just table stakes, really. The number that really jumps out, the kind of key insight here, is the sheer strength. Engineer-verified sheer strength.
Let's put that in context for everyone listening. Sheer strength. That's the force needed to basically break a connection, right? Make the structure fail at that point. What's the number they've verified?
Get this. They claim over 25,000 pounds of sheer strength per connection.
Whoa.
Yeah.
Okay.
To really appreciate that, think about a standard wood frame connection, maybe a few hundred pounds, if that.
Mm-hmm.
Even the heavy-duty steel connections need serious welding or big bolts to get into the tens of thousands.
Right.
This system apparently hits 25,000 plus pounds with just a mechanical clamping system, rapid assembly. So you pair that crazy strength with the fact that it's lightweight aluminum, resists corrosion, you get a frame that's super durable and supposedly very fast to put together.
Wow. Okay, 25,000 pounds that's a serious number. But I have to ask the critical question here. Structural engineers, they can be a bit wary of aluminum for primary structures. Concerns about cost, maybe, or material fatigue over decades. How does the 170 series deal with those, real-world durability worries?
That's a fair point and a really necessary one.
Hmm.
The documentation we have suggests that switching to this system changes the cost equation. Yes, the initial material cost might be higher than, say, basic lumber or commodity steel, but the durability, the longevity, that changes the math. Because aluminum doesn't rust, maintenance costs should drop significantly. And fatigue. Well, the structural analysis needed for that QAI certification, we'll get to that, that has to verify the long-term integrity of both the extrusions and the connections.
Okay.
So the argument is the life cycle savings plus the guaranteed salvage value outweigh the initial cost premium.
Does the lighter series, the MHS 150, offer similar perks for, say, interior walls or smaller stuff?
It does. They have the MHS 150 series, too. It's lighter, designed more for compact modules, interior partitions, maybe outdoor shade structures, that kind of thing. But crucially, it uses the exact same MHS clamp system and accessories as the big 170 series.
Ah, so it's compatible.
Fully compatible.
Yeah.
They designed it as a whole family of parts, not just two isolated systems.
And you mentioned rapid assembly. How does it physically come together on site? We know about the prefabricated extrusions. What about the actual walls, the roof?
So they talk about fast assembly, and a big part of that is integrating the frame with SIP's structural insulated panels.
Okay, SIPs. I know those.
Yeah, specifically, they mention working with panels that have a 4.5-inch EPS core that's expanded polystyrene.
Right.
Using those pre-made insulated panels along with the aluminum frame means, in theory, much shorter project times and fewer labor hours needed compared to building a traditional stick frame on site. This is where that lower total life cycle cost idea really starts to make sense.
Gotcha. Okay, so that covers strong and lightweight pretty well. Now let's hit certified, because fancy engineering is kind of useless if you can't actually get a permit to build with it right.
Yeah.
How do they back that claim up, especially for international use?
This is absolutely critical, especially if they're aiming for global scale. They've secured a QAI code evaluation report. The specific number is Series 6039.
Cirrus 1039.
And this report confirms it meets major North American building standards. The 2021, 2018, and 2015 versions of the International Building Code, IBC, and the International Residential Code, IRC, plus the 2022 California Building Code, the CBC.
Why is having that specific list of codes so important for someone thinking about using this globally?
Because the IBC especially is recognized and often adopted or at least used as a benchmark all around the world for safety and structural quality.
Ah, okay.
Having that comprehensive certification basically removes a massive hurdle for potential partners overseas. It should drastically reduce the local engineering reviews and testing costs that usually slow down bringing new building systems into different countries. It's like giving the licensee a pre-approved certified product.
Okay, this is where it gets really interesting for me. We know it's strong, certified. We look at the actual components. What are people building with this system? What are the physical pieces that allow for all this design flexibility they talk about?
Well, the flexibility seems to come from two main things: the engineered aluminum profiles themselves and the quick connect hardware. They have different profile types. They call them MHS 04W extrusions.
04W, okay.
Yeah, and these are designed so you can run wiring or plumbing inside them, and then they have interior and exterior cover caps to finish them off. But the real functional cleverness seems to be in the connection itself.
Which is?
It's called the MHS clamp system set. It uses a steel-based piece and L-shaped connectors. Plus, there's some special C-caps and other bits designed just for that heavy-duty 170 series frame. Think of it like a really precise, pre-engineered Meccano set or Lego technique, maybe. It snaps and bolts together quickly, and that's how they maintain that huge 25,000-pound shear strength without needing complex welding or tons of on-site fiddling.
So you've got this super strong, high-performance skeleton, but what does it look like when it's finished? Are we just building functional boxes, or can you actually make these look high-end?
The frame itself is functional, yeah, but the potential for aesthetic variety seems pretty high. The source info mentions modern aesthetics with flexible integration.
Yeah.
The standard finish on the aluminum is just mill finish, basic, durable. But they do offer custom anodizing or color finishes as upgrades. And because the system is designed to work with all sorts of different wall claddings and finishes on the outside and inside.
Right, you wouldn't necessarily see the frame.
Exactly. The structural core becomes invisible. So you could, in theory, create some very customized, high-end looking buildings.
Let's talk applications then, because the scope needs to be big if the system is that ambitious.
Yeah.
If you have something strong, certified, and importantly, relocatable, what can you actually build with it?
The range they list is huge. It goes all the way from temporary shelters to permanent homes. On the residential side, they specifically mention ADU's accessory dwelling units.
Backyard tiny homes, yeah.
Right, and mobile homes. Also mobile trailers and shelters. The fact that the frame itself can be taken apart and moved makes it seem ideal for things like temporary or emergency housing.
Makes sense. And on the commercial side?
Even broader, it seems, mainly because of that easy assembly and disassembly. They list things like office pods, custom store fixtures, like retail displays maybe, and definitely temporary structures like trade show booths, event structures, exhibit systems.
Okay.
They even mention using the components just for interior walls and partitions, or on the outside for things like solar panel frames and shades.
That versatility really ties back to the economic benefits you mentioned earlier, doesn't it?
It does.
Because the parts are reusable, relocatable. You could break down a trade show booth and maybe reassemble the frame into an office pod later. That dramatically lowers the life cycle cost and makes the asset itself more durable, especially compared to traditional construction that just gets demolished.
Precisely. That reusability, plus the guaranteed high salvage value of the aluminum itself, those are really the core pillars of their sustainable claim. They're treating the building parts like assets, not like throwaway consumables.
Okay, let's switch gears a bit. From the physical product to the business model, the licensing ecosystem. If a company, maybe a big developer or builder, wants to actually use this tech, how do they partner with MHS? This is where that promise of rapid, repeatable global rollout really gets tested.
Yeah, and the whole model seems built around getting licensees up and running and seeing a return on investment quickly. They want to avoid MHS having to build everything themselves centrally.
Right. Scale through partners.
Exactly. So they lay out a few main ways for companies to get involved regionally, becoming an authorized fabricator or an authorized builder or maybe just a distributor.
What's the main difference between those roles?
Well, a fabricator would likely get the raw aluminum extrusions and actually assemble the frames in their region. A builder would probably buy the completed frames and then integrate them into the final buildings. And a distributor is more focused just on reselling the system or components.
Okay.
You can also apparently negotiate for exclusive rights, maybe for a whole country or region, or even look at joint venture options, JVs, for setting up turnkey module factories.
Wait, unpack JV for us. What does a joint venture look like here?
A joint venture, or JV in this context, likely means MHS would partner directly with a large regional company. Maybe they'd co-invest to build a brand new factory, specifically to produce modules using the MHS system.
Ah, okay.
This seems like the path for the really big players, the ones who want full control over the supply chain and manufacturing in their territory. It goes way beyond just buying and selling frames.
So if I sign up, become a fabricator, or get into a JV, what kind of support do I actually get? Using a new certified system like this needs specialized knowledge, right? Especially with engineering tolerances, local code variations.
They seem to offer a pretty comprehensive support package. It looks almost like a turnkey technical setup. You get full access to the core engineering data, all the load tables you'd need, and this is important, access to the actual extrusion dies.
The dies, you mean the molds to make the aluminum profiles?
Exactly. That means licensees could potentially start fabricating the specific aluminum profiles themselves regionally instead of having to import every single piece from MHS.
That's huge for logistics, avoiding long shipping times. What else is in the support package to make sure quality stays high and everything is compliant?
There's ongoing technical and design support, apparently comprehensive training for the local teams who will be doing the fabrication or building, and guidance on navigating code compliance in different areas. Plus, they offer structural and architectural engineering consulting, help the whole design to manufacturing workflow, and all the necessary quality control documentation templates. Licensees also get to use the MHS trademarks and marketing materials, and they promise access to future system updates and innovations.
Okay, let's talk logistics. Where is this stuff actually made right now, and what about minimum orders? This is where the barrier to entry often pops up.
Right. The documentation we reviewed says the extrusions are currently fabricated in the USA, specifically FOB Long Beach, California.
FOB Long Beach, okay? Standard shipping term.
Yep. And they handle global shipping, by truck within North America presumably, or container overseas. The typical lead time they state is around 2 to 3 months, which honestly for industrial components like this seems pretty competitive.
Okay, but let's get to the scale question. They're clearly not targeting DIYers here. They want industrial partners. What's the minimum order size?
It's substantial. The minimum order is listed as 20,000 to 30,000 pounds per extrusion series.
Wow, 20 to 30,000 pounds. That's a lot of aluminum.
It is. This is definitely not for one-off small projects.
So that minimum, why so high? Is it just to filter out smaller players, or is there an economic reason tied to manufacturing these kinds of profiles?
I think it's probably both. It acts as a filter, ensuring partners are serious about large-scale deployment. But there's also a manufacturing reality. Setting up and running the extrusion dies for these complex custom aluminum profiles is only really cost-effective at large volumes.
Right, economies of scale.
Exactly. This minimum ensures the unit cost per frame can stay competitive against traditional methods. It also likely helps prevent competitors from just ordering small batches to try and reverse engineer it. It basically locks partners into operating at the intended industrial scale.
That makes sense. It forces the kind of industrial adoption they need. Okay, last piece on the business side, the paperwork. What are the legal steps before I can place that order for, 15 tons of aluminum?
It looks like standard procedure for this kind of B2B tech transfer. You need to sign an NDA, a non-disclosure agreement first. Then there's a comprehensive licensing agreement outlining all the terms.
Makes sense.
Payment is handled via a proforma invoice, and it requires prepayment.
Hold on, what's a performance invoice again? Exactly. How does that work?
So a proforma invoice is basically like a preliminary bill. It confirms the seller's commitment to provide the goods at a specific price, but it's issued before production or shipment really kicks off.
Oh, okay.
Given these are custom, large-scale industrial orders, needing prepayment makes sense. They also mentioned a non-refundable deposit is required, but that deposit gets credited towards your actual order later. It's all designed to lock in commitment efficiently from these big regional partners.
So, putting it all together, what does this really mean for the construction world? It looks like a model designed from the ground up for global scale. It promises lower life cycle costs, a smaller carbon footprint compared to traditional framing. It seems very leveraged, very repeatable.
Absolutely. What we've sort of unpacked here is a modular system based on, well, proven aluminum technology, but pushed to a high level of strength. Remember the 25,000 plus pounds shear strength.
Right, that number 6 with you.
Yeah, that's the bedrock. And it's certified, which is key. It enables rapid, sustainable building across a really wide range of uses, and it's all driven by this supported, repeatable, industrial-scale licensing model for regional partners.
The long-term vision seems to be not just about building faster, but fundamentally building smarter, thinking of the building structure almost like a reusable kit of parts.
Exactly that. You're combining really high durability that corrosion-resistant aluminum means lower maintenance, lower life cycle costs, with the certainty of high reusability and the fact that it's 100% recyclable at the end of its life. That's pretty much the definition of a sustainable structural investment, isn't it?
It really makes you think. And this brings us to a final question, something for you, the listener, to consider as this kind of technology potentially scales up globally. If you have a structural frame that's certified strong enough to handle over 25,000 pounds of shear force per connection, but it also promises high salvage value and complete reusability, even relocatability, does modular construction shift from being seen as maybe a temporary or secondary option to becoming a truly permanent yet still fully adaptable primary way to invest in buildings? Think about how that could change the economics of owning and managing property long term.